Welcome to the deep dive. Today, we're cracking open the world of FortiGate firewalls. Whether you're deep in managing a complex network or maybe just curious about how all this digital traffic gets protected, well, this should give you some valuable insights.
Absolutely. We've really dug into some focused Q&A material from FortiGate experts. It's like getting a concentrated shot of their hands-on experience, all aimed at boosting your understanding of network security.
Yeah, and our mission today is pretty straightforward. Pull out the most vital info on how these firewalls actually work. We want to look at their key features, how they handle traffic, the security stuff baked right in. Really just demystify some of the techier bits.
Sounds good.
Okay, so let's start at the foundation. Network translation.
Right. So fundamentally, you need a way for your private internal network devices to talk to the public internet and vice versa. That's where NAT, network address translation, comes in. Think of it like a translator. And there are, well, two main ways this happens. You've got your standard NAT, which is often one-to-one, mapping a private IP to a public one, but more common is PEAT, pert address translation.
Ah, PFTT. Yeah, that's the clever one, isn't it? Where lots of internal devices can share just one public IP address.
Exactly. They're kept separate using different port numbers, like an office building with one main number, but lots of extensions.
Gotcha. So how does FortiGate handle this specifically? What are the mechanics?
Okay, so FortiGate uses what it calls source NAT for traffic leaving your network. Your internal IPs get hidden, basically. It often uses something called IP pools for this. Think of it as a stash of public IPs the FortiGate can assign.
Okay, that's outbound. What about traffic coming in, like someone trying to reach a server on my network?
All right, for inbound traffic, FortiGate uses destination NAT, or DNet. And this is usually set up using virtual IPs, or VIPs. These VIPs map a public IP and port to a specific internal server's IP and port. You configure these under policy and objects, then IPv4 policy and objects, and then virtual IPs.
Right, right. So the VIP is the key for that incoming connection, finding the right internal machine. Like a web server example, maybe.
Perfect example. Someone types your public IP into their browser. The FortiGate sees this, checks his VIP rules, and says, this needs to go to internal server 192.168.1.0 on port 80, and sends it there. DNet in action.
Okay, clear. It's like the network's receptionist directing the call.
Exactly. Now, building on that, sometimes just translating addresses isn't enough. Some protocols are trickier. That brings us to session helpers.
Session helpers. Okay, they sound specialized. What's their job?
Well, think about protocols that don't just use one single port for everything. They might set up a control connection on one port, but then negotiate other, dynamic ports for the actual data. Session helpers understand these protocols. Their job is basically to watch the traffic for these specific protocols and make sure the firewall doesn't accidentally block those dynamically open ports. They're protocol-aware assistants, you could say.
Can you give an example? Make it concrete.
Sure, FTP is the classic one. File transfer protocol. It initiates control on port 21, we all know that. But when you actually transfer a file, it opens up different, often random ports for the data itself. Without a session helper, the firewall might see that initial port 21 traffic, but then block the subsequent data transfer on those other ports because there's no specific rule for them. The FTP helper anticipates this and keeps track.
Ah, I see. So it knows FTP's little quirks. That makes sense. Could having unexpected session helpers running indicate something weird?
That's actually a sharp point. Yeah, sometimes seeing unexpected helpers active could potentially signal malware trying to use non-standard communication channels. It's something to be aware of.
Interesting. How do you actually see which helpers are running on a FortiGate?
You'd use the CLI, the command line interface. The command is show system session helper. That'll list out all the active ones.
Okay. And can you turn them off if one seems to be causing trouble,
Right.
maybe?
Yep, absolutely. Say you're having issues with SIP for voice over IP. You could try disabling the SIP session helper to see if it helps. You typically do this under config system settings for the default VoIP handling, or you can target a specific helper under config system session helper and delete it. But, be careful. Disabling a helper will likely break the protocol it's designed for, so use with caution.
Right. Caution advised. Okay, let's shift a bit. FortiGate inspection modes, flow-based versus proxy-based. What's the core difference?
This is a really important distinction. It impacts performance and how deep the security inspection goes. Flow-based is, well, flow-based. It inspects traffic pretty much in real time, packet by packet as it flows through. It looks at headers, maybe a bit of content, but doesn't wait for the whole file or session. This means it's fast, lower latency. Great for networks where speed is critical.
Okay, flow-based equals speed, like a quick ID check at the gate. What about proxy-based then?
Proxy-based is more like, well, bringing the whole suitcase in for inspection. It buffers the entire session or the entire file transfer. Once it has the whole thing, it does a much deeper analysis. This is where you get really effective data loss prevention, or DLP,
Yeah.
because it sees the full context, and more thorough AV scanning, because it can scan the entire file.
But I guess that takes longer.
Exactly. It uses more system resources, CPU, memory, and introduces a bit more latency compared to flow-based.
So it's a trade-off, speed versus depth of inspection. When do you pick which?
Generally, flow-based is good for high-throughput needs, maybe where you have other layers doing deep inspection elsewhere. Proxy-based is often the choice when that details content inspection is absolutely critical. Think compliance requirements or environments super worried about data leaks.
And can you mix and match?
You can. That's the neat part. FortiGate lets you set the inspection mode per policy. So for different types of traffic, you can choose flow or proxy. You do that in the CLI and configure the firewall policy. Then you set inspection mode to either proxy or flow. Very flexible.
That is flexible. Okay, super important topic now. Keeping things running. High availability, or HA. What are the options here?
Right. HA is crucial for avoiding downtime if a firewall fails. FortiGate offers a few ways to do this. The most common is probably active-passive, or AP. One firewall handles all the traffic, that's the active one. The other one just sits there, ready, in standby. If the active one fails, the passive one takes over almost instantly.
Like having a hot spare ready to go.
Exactly. Then there's active-active, AA mode. Here, both units are processing traffic. With FortiGate, this usually involves session-aware load balancing. It tries to distribute the load, but importantly, it makes sure all packets for one specific connection stick with the same firewall. That avoids breaking things.
Okay, session aware. Got it. Any other modes?
There's also virtual clustering. This lets you sort of group multiple physical units and distribute the load based on VDOM's virtual domains, which we can touch on later.
So what makes HA tick? What are the essential bits?
Several key things. First, heartbeat interfaces. These are dedicated links, physical or logical, between the HA units. They constantly send "I'm alive" messages back and forth. If one stops hearing the heartbeat from the other, it knows something's wrong. The speed of these links matters for failover time, by the way.
Okay, heartbeats. What else?
Then you have priority and override settings. Priority decides which box should be active. Higher number usually wins. Override determines if a unit that failed, but now recovered, should immediately take back control if it has a higher priority. Sometimes you want that, sometimes you don't.
Right, control over failback.
And finally, especially in active-passive, session synchronization is vital. The active unit constantly sends updates about all the current connections, who's talking to whom, over to the passive unit. So if a failover happens, the passive unit already knows about all those existing connections and can just pick them up without dropping them.
Smooth transition. You mentioned a CLI example for setup.
Yeah, a basic AP setup under config system would involve setting the mode AP, giving it a group name, specifying the HPDev heartbeat devices, setting a priority, and enabling or disabling override. Pretty straightforward commands.
Gives you a feel for it. Okay, sometimes traffic doesn't play nice, right? It goes out one way and comes back another. Asymmetric routing.
Exactly. Asymmetric routing. Traffic from A to B takes path X, but traffic from B back to A takes path Y. FortiGate, by default, doesn't really like this. It expects to see both sides of the conversation pass through it, so it often drops the asymmetric traffic.
Why drop it? Is it purely a security thing?
It's partly security, yeah. Asymmetric flows can sometimes be exploited or indicate weird network setups, but it's also about state tracking. Firewalls like to keep track of connections, the state. If it only sees half the conversation, maintaining that state gets messy and unreliable.
Okay. So if you think this is happening and causing problems, how do you troubleshoot?
First step is usually checking the logs. The GUI logs, or more powerfully, using diag debug flow in the CLI, we'll get more into that specific command later. It can show you if packets are being dropped due to things like a reverse path check failing.
And if it turns out the asymmetric routing is actually intended, maybe due to complex routing?
Then you can tell the FortiGate to allow it. Under config system settings, you can set asym route enable. You can also use diaxis session list to look at session details. Sometimes the TTLs give clues. And in an HA pair, enabling session pickup can sometimes help manage these sessions better across the cluster.
But you'd only enable asym route if really necessary, right? It sounds like it has risks.
Absolutely. That's the big caveat. Enabling it can potentially open security holes if not done carefully and with full understanding of your network flows. Only do it if you have to and know why.
Important warning. Okay, let's talk UTM, Unified Threat Management. FortiGate gets called a UTM device all the time. What does that actually mean in practice?
It just means it bundles a whole bunch of different security functions into one box. Instead of needing a separate firewall, a web filter, an IPS device, an antivirus gateway, FortiGate aims to do most or all of that.
Right, integration. So what are the typical UTM features we're talking about on a FortiGate?
The usual suspects are antivirus, of course, scanning for malware, web filtering, controlling access to websites by category or reputation, application control to identify and manage specific apps like, say, BitTorrent or Facebook. Then there's IPS, intrusion prevention system, looking for known attack patterns, email filtering for spam and phishing, and DLP, data loss prevention, trying to stop sensitive data leaving the network.
That's quite a suite. How do you actually apply these to traffic?
They're configured in what FortiGate calls security profiles.
Hmm.
You'd create an antivirus profile with your desired settings, a web filter profile with your rules, an IPS profile, and so on. Then you attach these profiles to your firewall policies. So when traffic hits a policy, whatever security profiles are linked to that policy get applied.
So the policy is the trigger. Can you show a quick CLI example of adding profiles to a policy?
Sure. Let's say you want to add the default antivirus profile and the WF default web filter profile to policy number 1. You'd go config firewall policy, then edit 1, then set antivirus profile default, set web filter profile WF default. You might also add an application list, like set application list app default. Done.
Okay, that paints a clear picture of the integration. Now, you keep mentioning diagnose debug flow. It sounds like the ultimate troubleshooting tool. How do you use it effectively?
It really is powerful. It gives you a packet-by-packet account of what the FortiGate is doing with specific traffic. You see every decision step. If you're trying to figure out why, say, Bob can't access a server, this command is often your best friend. Seeing allowed by policy in the output is often the first sign you're on the right track, or that the problem lies elsewhere.
So what's the process? How do you run it?
Okay, typical sequence. First, clear out any old debug settings with DOIG debug reset. Then turn debugging on with DIG debug enable. To see the output live in your terminal, use DIG debug flow show console enable. Crucially, you need to filter it so you don't get flooded. Use DIG debug flow filter. Maybe filter adder followed by the source or destination IP you care about. Then start the trace. DIG debug flow trace. Start, and usually give it a packet count, like 100. It will then show you the processing for the next 100 matching packets.
And what sort of messages are you looking for in that output? What tells you what's happening?
Key messages include allowed by policy, good sign. Denied by policy tells you which rule blocked it. No matching policy means the traffic didn't fit any rule. You might also see things like reverse path check failed, which, as we said, points towards asymmetric routing issues, or messages about NAT translations happening.
Super useful for diagnostics. And when you're finished,
Critically important, turn it off. DIG debug disable. Leaving debug running can really hammer the CPU and affect performance, so always remember to disable it.
got it. Disable when done. Okay, we've talked about lots of individual pieces. How does it all fit together? When a packet hits the FortiGate, what's the actual step-by-step process, the order of operations?
Understanding this flow is key. So a packet arrives at an interface. First, the FortiGate checks its session table. Does this packet belong to a connection it already knows about? If yes, great. It usually just processes it quickly based on the existing session state. If it's a new connection, it needs to check the firewall policies. Does this packet match a rule, source, destination, service, etc.?
Okay, policy lookup. What's next if it finds a match?
If it matches a policy, then the security profiles attached to that policy get applied. AV, IPS, web filtering, app control, whatever is configured. After the security checks, NAT happens if the policy dictates it, source NAT or destination NAT. Then the FortiGate needs to figure out where to send the packet next, so it does a route lookup.
Finds the next hop or the outgoing interface.
Exactly. Sends a packet out that interface. And finally, it updates the session table, either creating an entry for this new connection or updating the timers for an existing one.
Incoming interface, session check, policy match, security profiles, NAT, route lookup, outgoing interface, session update. That makes sense. A logical flow.
It is. And knowing that order helps you troubleshoot, because you know when certain things should happen. Like NAT happens after the security profiles are checked in many cases.
Right. Okay, another concept, VDOMs, virtual domains. You mentioned them earlier. What are they and why use them?
VDOMs basically let you slice up one physical FortiGate box into multiple independent virtual firewalls. Each VDOM acts like its own separate firewall. This is super useful for things like maybe different departments in a company needing totally separate security policies, or for managed service providers who handle security for multiple clients on the same hardware. or even just for creating really distinct security zones within your own network. It uses virtualization built into the FortiOS to achieve this isolation.
Interesting. Like virtual machines, but for firewalls. You mentioned two modes, split task and multi-VDOM.
Yeah, in split task mode, you usually have one VDOM dedicated just to managing the FortiGate itself, and then other VDOMs handle the actual network traffic. It separates management from data flow. Multi-VDOM mode is where each VDOM is completely separate. Its own policies, its own routing, its own admin logins, like having totally separate boxes, just sharing the hardware.
That sounds incredibly flexible for administration. How do you actually switch modes? Is it difficult?
Nope, it's a global setting, usually done via the CLI. You go into Config System Global, and then you use Set VDOM Mode Multi-VDOM to enable it. The default is Split VDOM, so you'd use Set VDOM Mode Split VDOM to go back if needed. Requires a reboot, usually.
Good to know. Okay, last big area, performance. How do you keep your FortiGate running smoothly and efficiently? Any top tips?
Definitely. We've touched on some already. Using flow-based inspection instead of proxy-based where possible is a big one for reducing load. Also, FortiGates have special hardware acceleration chips, NPUs, network processor units. Understanding how traffic gets offloaded to these NPUs can be key. Make sure your traffic patterns allow for this offloading.
Hardware acceleration, right. What else?
Enabling session TTL optimization can help the firewall clean up old, inactive sessions faster, freeing up memory. If you have lots of users accessing the same web resources, maybe consider using explicit web proxies for caching. And honestly, one of the simplest but most effective things is keeping the firmware up to date. Fortinet often releases performance improvements and optimizations in newer firmware versions.
Regular updates. Good practice anyway. Are there quick ways to check how the box is doing performance-wise?
Yeah, a couple of key CLI commands.
Yeah.
AX's top is like the top command on Linux. It gives you a live view of CPU and memory usage by process. Really helpful. And diag hardware size info memory gives you a detailed breakdown of memory usage. Good for spotting if you're running low on RAM.
Diag systop and diag hardware info memory.
Got it. Wow, okay. This has been, well, definitely a deep dive. We've gone from NAP basics all the way through VDOMs and performance tuning, covered session helpers, inspection modes, HA, asymmetric routing, UTM, that powerful debug tool. It feels like a really solid overview.
I think so too. It covers the core concepts you really need to grasp to understand how these devices operate and how they protect networks. And when you step back and see how all these layers, the UTM features, the ordered processing work together, it really highlights the thought that goes into modern network security. It's complex stuff. Absolutely. So maybe a final thought for everyone listening. How does this idea of layered security, which FortiGate embodies pretty well, relate to your own digital world? You know, think about your home network or just your general approach to security online. Do you have layers? And thinking about all these FortiGate features, the inspection types, the helpers, the routing checks, which concepts felt most relevant, or maybe shed light on some network oddity you've experienced yourself. It's definitely worth pondering which of these areas you might want to dig into more, or how they connect to those real-world network puzzles we sometimes encounter. Thanks for joining us on this deep dive.